Hello and welcome to this video on Ansys Twin Builder for battery cell equivalent circuit modeling using the battery wizard. So I've launched Twin Builder. I'll access the battery wizard by going to the menu Twin Builder, down to Toolkit, Battery Wizard. I've set the working directory to be the directory where I have my HPPC data. Click on Cell Configuration Tool. Since there's no folders there, I'll create a new one. I'll use the 6 parameter for the ECM parameters. Independent variables will be SOC and temperature. So the HPPC data has 13 levels of SOC values and 2 levels of temperature. I'll update the cell capacity to 56. I'll leave the rest of the options to default. For cell parameters, I'll switch to HPPC data and then browse for the folder, which should be the same for me as the working directory. And then click on generate. And once that's complete, I'll accept. And one could visualize the curves so we can see the data as well as the curve fit. And that would be for, in this case, 26 different curves. So I'll close that, close the cell configuration tool and the battery wizard. So now we have a battery cell component within the components library. We'll drag that into the schematic, zoom in a little bit, and then I can rotate. Start adding some components for a circuit. First one will be a constant for the temperature. We'll change that temperature to 293.15 Kelvin. Okay. Then we'll add a amp meter. We'll rotate that as well. Add a voltmeter. Put that here. And then a current source. That over here. Rotate that one twice. And last component to add would be a ground. I'll put that below. And now we can start connecting. So connect the temperature constant to the temperature input. Connect the battery positive cell to the amp meter. Connect the voltmeter to that line. Connect the source to the amp meter. Connect the source to the ground. The source to the amp meter over here, and then the voltmeter to the negative terminal of the battery. We'll update the source to time controlled with a shape that's trapezoidal. We use an amplitude of 10 amps, delay of 20 seconds. Keep the rise as 0.005. Keep the fall as 0.01. We'll update the width to 10 seconds. And now we'll go and define our results. So we'll right-click on results, then create standard report, rectangular plot. Here in the quantities, for the first one, I'll pick the amp measurement AM1.I, new report down here. Then the same thing for the voltage, so VM1.V, new report. And then the battery cell 1.power loss new report. So I've created those 3 reports. They show up here in the project manager. One could rename as desired. Then we go up to Analyze, right-click on TR, click on Edit. We'll change the end time to 200 seconds. The minimum time step size, 0.01 seconds, and the maximum time step size of 5 seconds. Click OK, then back to Analysis, right-click, Analyze, and wait a couple of seconds for the run to complete. So now we can see our battery cell power loss over time. You can go back and do an opening report to see the current, the delay of 20 seconds, the width of 10 seconds, and then the amplitude of 10. And we could open the voltage as well. And then back here to the battery cell, one thing I like to do is to do a export. So right-click, export, and then one can export out a CSV file to open in a spreadsheet. That's it. Thank you for viewing, and goodbye.